one story. So today we are going to start small signal low frequency equivalent circuits. So far we have seen that how a transistor can be used as an amplifier and what is the necessity of biasing, what is operating point, what is load line, and the justification of operating point to get maximum amplification without any distortion. Okay, so we have seen all the device characteristics. So far we have seen the device characteristics. Our device will behave, the electrical behavior of the device by giving some external voltage or the current and voltage variations are there in the device. Now here in this chapter we will be concentrating on the amplifier analysis. In third unit we have discussed only how transistor can be used as an amplifier, how it amplifies the signal. And here we will see in detail the analysis of common emitter amplifier, common base amplifier, common collector amplifiers. The analysis of common emitter, common base, common collector amplifier includes finding the performance assessment parameters. This is very easy chapter. So the performance assessment parameters are the current gain, voltage gain, input resistance or input impedance, output input. So these are the four important parameters which we are going to derive in each and every amplifier configuration. So what is the current gain, voltage gain, input impedance and output impedance of CV amplifier in common base amplifier conflict and common collector amplifier. So once we find these parameters for all these three amplifiers, then we can compare easily. So then we can compare the performance of each amplifier over the other. So that is why these are called performance assessment parameters. And in addition to that, once we derive these parameters, then we will know where the applications of each amplifier. So based on the current gain, voltage gain, input and output impedances, so where we can use these amplifiers, what are the applications. So that also we will come to know only when we derive these performance measurement parameters. So using these parameters, with the knowledge of these parameters, you can compare them, and you will also know the applications where we can use them. So before we derive these parameters for each amplifier, let us see what is a small signal low frequency equivalent circuit. So the name of the chapter is small signal transistor equivalent circuit. So the meaning of small signal is that, so we will justify first this topic. So once the transistor is properly biased, once the biasing is properly done to the amplifier, as soon as we give some AC input signal, it will increase the strength of the signal. That is, it will, so the signal is said to be amplified. And that amplified signal will be delivered to load. So if Vs is the input signal coming from the source, and if A is the gain of that particular amplifier, then the output signal is going to be A into E. So this is the amplified signal which will be delivered to load. So here, depending upon the strength of the input signal which we are going to give to the amplifier, depending upon the strength of the input signal which we are going to give to the amplifiers are basically classified into large signal amplifiers and small signal amplifiers. Large signal amplifiers and small signal amplifiers. Small signal and large signal. So why the name has come small signal means here the strength of the input signal, the strength or peak to peak amplitude. So strength is going to be strength of input signal. Strength of input signal is small, that transistor always that transistor is always operated in active region. Transistor will be operated in the active region. Here, if the input signal is large, then input signal strength is large, the transistor may be operated in saturation and cutoff as well. In saturation and cutoff as well. In addition to the active region, transistor may enter into the saturation and cutoff. So while the strength of the input signal is said to be small, if you remember the load line, this is the operating point. Let us say one output characteristic curve if we take IB. Then as soon as you give some AC input signal, then AC base current will be flowing. AC base current is superimposed on its DC. So here the strength of the input signal is such that the transistor always lies in the active region. So this thing of the input signal always lies in the active region. Whereas in the large signal, you take the same load line, you point, if this is the output characteristic curve, IB some 10 microamperes DC, and large signal meaning is that the strength of the input signal is going to be large, that some portion of the positive peak and some portion, you observe here, they are entering into saturation and cutoff. It means transistor may enter into the saturation region and cutoff region as well. So this is the meaning of small signal and large signal amplifiers. So in small signal, we can guarantee that transistor is always in active region. It is, it may enter into the saturation and cutoff your algorithm. It may enter into saturation and cutoff as well. And the second is that the example of small signal amplifiers, we can call all the voltage amplifiers, all the voltage amplifiers comes under small signal amplifier, and all the power amplifiers. Power amplifiers are examples of large signal amplifiers. So these power amplifiers you will be studying in the next semester. But here we will be studying about the small signal amplifiers. So this is the meaning of small signal amplifiers. Okay. Now a model which represents the physical behavior of the amplifier in the active region. So we are concerned only about the small signal amplifiers in fourth unit. The small signal implies that transistor remains in the active region. The positive and negative peaks of the input signal, that is ping of the input signal, always it will be within the active region. So a model or the equivalent or a circuit which exactly represents the physical behavior of the amplifier in the active region is called small signal model of the transistor. The small signal model of the transistor. The small signal means it is the equivalent circuit. The circuit which exactly behaves as that of the physical operation of the transistor. Circuit behaving circuit representing the physical behavior. The circuit representing the physical behavior of the transistor is called the model. Now, this is also called as model or equivalent circuit. Equivalent, same, equivalent circuit. So, wherever transistor symbol is there, emitter, base, and the collector. So, whenever transistor symbol is there, this transistor, now onwards, wherever transistor symbol is there, now onwards, is replaced. It will be replaced with its equivalent model. It will be replaced with its equivalent small signal model. Small signal model. One second. So here onwards, whenever we come across the transistor circuit, whenever we come across the transistor circuit, the transistor will be replaced with its equivalent model. So now we will see. Next, we will derive what is that model. So for that, we need to recollect some of the transistor fundamentals. Okay. So we know that transistor BJT is a current controlled current device. Is it right? So output current, we recollect output current is a function of input current, because for all the three configurations we have a relation between output current and input current. IC is approximately equal to alpha IB, IC is approximately equal to beta IB, and IE is approximately equal to gamma IB. So this is for CB, CE, and CC. So these equations clearly indicates that transistor is a current output current is dependent on the input current. Now in addition to that, the shape of the input and output characteristics are accounted by the effect called early effect. So early effect. So the early effect is that the change in the reverse bias voltage, the change in the reverse bias voltage at the collector junction modulates the width of the base. So this is called early effect, and there are consequences of early effect, that alpha increases, emitter current increases. So it means indirectly output current also depends on the output voltage. Indirectly output current also depends on the output voltage. So this is the with this with this we we have taken that input current, output voltage are independent variables, and the remaining two, what are the remaining two? Input voltage and output current are dependent variables. Dependent variables. So the transistor in any configuration, whether it is in CB, CA, or CC, has two terminals at the input side and two terminals at the output. So therefore, transistor can also be treated as a, we can treat transistor as a two-port network. We can say that transistor also acts like a two-port network. So let these are the 1 dash, the input terminals, 2 dash, the output terminals. So let I1 is the input current, V1 is the input voltage, I2 output current, V2 output voltage. So just now we have arrived at the conclusion that output current. See equation, this equation from this we can write that output current output current is a function of in BJT output current is controlled by input current. Therefore, output current is a function of input current I1, comma output voltage V2. Output voltage V2. So in a similar way, we have one more dependent variable, that is V1 is equal to so I1 comma V2 are taken as the independent variables and V1 and I2 are taken as the dependent variables. So you need to remember this too. So this equation is so this you need to remember output current is dependent on the input current and output voltage. So this equation is very important. Yes. So with this equation only we are going to derive the equations and equations corresponding to the model, and based on those equations we will draw the model. Now so we know that from the transistor characteristics electrical behavior, we have come to know that output current is a function of input current and output voltage. Okay, and input voltage is a function of, but we don't know the exact relation. But we don't know the mathematical equations which relate these parameters. Okay, so we have a different two-port parameters which relate the terminal voltages and terminal currents, like Y parameters, Z parameters, H parameters, ABCD parameters. ABCD parameters. So the two-port network, the terminal voltages and currents in a two-port network can be related mathematically with the help of these parameters I, Z, H, and ABC. But now here also we are saying that transistor can also be treated as a two-port network. Therefore, now I will make use of one of these parameters to relate the dependent and independent variables. So among these four parameter types, I am going to select H parameter type. So we are going to take H parameter model. We are going to take H parameters for transistor. So we are going to take H parameters for the transistors, because why I am taking H parameters for the transistor means even in H parameters also the same I1 comma V2 are taken as independent and I2 comma V1 are dependent. This is one reason why I am taking H parameter. And another reason is that okay, I will tell you the another reason. So therefore, based on this, the H parameter H parameters are used, H parameter model is used to represent the transistor in active region. The H parameters are used to represent the transistor in active region. Now I will write the equations of H parameters. Now I will write the equations of H parameters. V1, I2, in terms of I1, V2. So these are the two equations based on which the small signal model of the transistor has been derived. So we just know that it is a function of, but we don't know how exactly they are related. So the proportionality constants are H11, H12, H21, H22. These are called as the hybrid parameters. So these are called as H11, H12, H21, H22. So these are called as hybrid parameters. H stands for hybrid parameters. Now these are the two equations. These are the two equations which exactly represents the physical behavior of the transistor. Which exactly represents the physical behavior of the transistor. And the definitions of the H parameters are, so from equation 1, so from equation 1, from equation 1, H11, I am writing it as V1 by I1 with V2 equal to 0. So when we set V2 equal to 0, H11 can be written as V1 by I1. What is V1 by I1? V by I? What is V by I? What is V by I?
Impedance.
Impedance. But here, what voltage and current we have taken? V1, I1. So these are related to the input port 1. So input voltage by input current. So how it represents? What it is representing? It represents the
Input impedance.
input impedance with, with output terminals short circuited. With output terminals short circuited. So in a similar way, if you define H12, use the same equation H12. I will use the same equation. Now from the same equation, please read out H12. How can we write H12? H12 is V1 by, yes, V1 by V2 with I1 equal to 0. So what is V1 by V2? Input voltage by output voltage. Input voltage by output voltage. If it is an output voltage by input voltage, then we would have called it as voltage gain. Output by input means it is a voltage gain, but here it is reverse. Therefore, the name of this H parameter is reverse voltage transfer ratio. Reverse voltage transfer ratio. Reverse voltage transfer ratio with the input terminals open circuit. Okay, sir. Now, using equation 2, from equation 2, what will you write? H21, H21, from equation 2, H21 can be written as I2 by I1. See, I2 by I1 with V2 0. So, with V2 equal to 0. So, what is the name of this H21? Can anyone tell what we will call H21? I2 means what? Output current. I1 input current. So, output current by input current. Yes,
Current gain.
Current gain.
current gain. ఇక్కడ చూడండి. See, we have called here as reverse voltage transfer ratio. So here I will call it as forward current gain. Now I will call it as forward current gain. Forward current gain. Current gain with output terminals short circuited. So the last parameter is H22. Last parameter is H22. So H22 is, you tell H22, what is H22? The ratio of second. It is the ratio of I2 by V2. I2 by V2 with my equation చూడండి H22 while defining H22 you need to set this I1 0. So then H22 can be written as I2 by V2 with I1 0. So with I1 equal to 0. So what we call this? I2 by V2?
Output impedance.
No, output admittance. Output admittance. I by V. Output admittance with input open circuited input terminals. So if you observe all the four H parameters, this H11, this H11 is giving the H11 will give you the input impedance of the device, which is nothing but transistor. H12 will give you the reverse voltage transfer ratio. So if you 1 by H12 will give you the voltage gain. So H12 will give you the information about the voltage gain, and H21 will give you the information about the current gain, and H22 will give you the information about the output admittance. So if you know the output admittance, inverse of output admittance is output impedance. So why these are called hybrid parameters? Because all the H parameters are different. They are not same. They are not alike. One is input impedance, one is output impedance, one is voltage gain, the other is current gain. So all are different. So all H parameters are hybrid, that is alike. They are called hybrid parameters. They are called hybrid parameters and hybrid parameters. So even for the analysis of amplifier, we are exactly looking into these parameters only. Once we go back to the analysis, see here, the analysis of amplifier means what? Current gain, voltage gain, input impedance, output impedance. If you can find these parameters for an amplifier, then we can assess the performance of it, and we can also know where we can use this amplifier. So therefore, these are the four different parameters which are very very important to know the performance of an amplifier, and these four parameters can be obtained only with the help of H parameters. These four parameters can be derived only if you choose H parameters, and it is not possible with the all other parameters, because you take Y parameters, all the four parameters will be admittances only. It will give you only admittances information. And if you take Z parameters, it will give you all the four impedances information. Only impedances. And this is ABCD parameters. So we don't want impedances, we don't want all admittances, right? So we want to know the gains of the amplifier, and in addition to the gains, input and output impedances. So these all four which are required to analyze the amplifier. So this can be achieved only with the help of H parameters. That is why H parameters are chosen. And this is one reason, and the second reason is that whatever the dependent and independent variables are taken in the transistor, the same dependent and independent variables are taken in H parameter model also. So that is why we have taken H parameter. So how to remember those equations? How to remember those equations means, first you need to recollect the transistor operation, that output current is dependent on the input current. So this testifies that output current depends on the input current, and it also depends on the output voltage. This we have seen in earlier effect, how output current also changes with the early effect. So if you remember that output current is dependent on input current and output voltage, that equation is sufficient to identify which two are the dependent and which two are the independent. Okay. So output current, that is why output current and input voltage, so I1 comma V2. So these are the two independent variables. So same thing I have written here, I1 comma V2. So output current is a function of input current and output voltage. So we are left with only one variable, V1. So V1 also can be written as I1 comma. V1 can also be written in terms of I1 and V2. So I1, V2 is dependent, independent anukunte, remaining two will become the dependent variables. So this is just writing on what parameters it is dependent. Now these are the just equations which will give you the idea that I2 and V1 dependent on I1 and V2, but we don't know the exact relation. So the exact relation between these parameters, the exact relation between these parameters of transistor can be represented with these two H parameter equations. So these two H parameters will give you the exact relation, will give you the mathematical equations relating the dependent and independent variables. Same equations, the same equations, whatever we have written, function of removing the function and we have written the proportionality constant h11, h12, h21, h22. That's all. So these h parameters, these are the definitions of h parameters. One is the input impedance and output impedance, reverse voltage transfer ratio, forward current gain. So this is one equation, h parameter, this is this transfer ratio, forward current gain, output admittance. So these are the four parameters we are also looking into to analyze the performance of the amplifier. Okay. Now we have just come across the equations. So we know the equations relating the input and output, input voltages, output voltages, input currents and output currents. Now we have to draw the model. We have to draw the model. So we will draw the model later. First, I will write H11. What is H11? Input impedance. If you have any doubt how I have defined these four parameters, you can just let me know so that I will repeat it. Because these are the basics which are very, very important. Once you understood how the H parameter model is derived, how that circuit is drawn based on these equations, so based on these two equations only, we are going to draw the circuit. So based on these two equations, we are going to draw the circuit. And that is the H parameter model. So if you understand well about this H parameter models, why we have taken V1, V2, I1, I2, which why we have taken I1, V2 are independent and the other two as dependent. So if you can define them, you understand how I have defined them, it is going to be very easy for you. Just the mathematical analysis only. Analysis means deriving the mathematical expressions. So H11, and I will write it one more time for your sake. So I will write the first equation. I'll write the second equation because I know very well that output current IC is a function of input current and output voltage, right? So H11, H21 plus H22. I will write second equation. Next V1, H11 I1 plus H12 V2. Now just now we have seen that H11 is V1 by I1 with V2 equal to 0. Therefore, I am going to write H11 as from now onwards we will write H11 as HI, input impedance. So H11 is HI, and in a similar way H12 H12 we have called it as reverse voltage transfer ratio. Reverse voltage transfer ratio. So how we got H12? H12, how we got this H12? Then some H12 V1 by V2 I1 equal to 0. So therefore, I am going to call this H12 now onwards as HR, or reverse voltage transfer ratio. And the next one is H21. H21. So from this second equation, I can write H21 as I2 by I1 with V2 equal to 0. So this I can call it as, we called it as forward current gain. So how to denote this H12? How will you denote H12?
HF.
Yes, very good. HF, forward. Right? So H22. The last one is H22. We found that H22 is I2 by E2 with I1 0. With I1 equal to 0. So this we called it as output admittance. So how to denote, therefore how to denote this? How to denote?
H naught.
HO. So H. So H11 we are going to say it as HI. H12 is HR. H21 is forward current gain HF. H22 HO output admittance. Now if we use these H parameters, when we use these H parameters, we are going to add a second subscript. Suppose I am going to use these H parameters for common emitter configuration. So then what will I write? I will write in place of HI, I will write HI, HF, HR, HO. So I will add a second subscript. I will add a second subscript E indicating that the type of the configuration. The type of the configuration. Now we will summarize what we have discussed in today's class. All of you see here, what are these H parameters, H11, input impedance, output impedance, forward current gain, reverse voltage gain. This is the, remember, this is the input impedance of transistor, input impedance of the transistor configuration. This is the input impedance of the transistor configuration. And this is the current gain of the transistor configuration. These parameters are going to be different for different configuration. So these values of these set parameters will be different for CV and they are different for CB and CC because each transistor configuration will behave in a different manner. Therefore, these H parameters will give you the behavior of the transistor, right? So each configuration will have a set of H parameters. Each configuration will have a set of H parameters and they are going to be different from one transistor configuration to the other transistor configuration. Remember that these are the parameters of the transistor. The common emitter की ఉంటాయి H parameters, common base will have some H parameters, common collector will have its own H parameters. So H parameters, right? So this is the output admittance of CE configuration. This is the reverse voltage gain of CE and current gain of CE. So suppose if we talk about CB, if we talk about CB, the same H parameters we are going to write as HIB, HI, HR, HF, HO. Now for common base, we are going to add second subscript to B, HIB, HRB, HFB, and HOB. Input impedance, transfer ratio, forward current gain, with output admittance of common base. And here I would tell you HF is the forward current gain, is the forward current gain, right? So whatever alpha, beta and gamma we are calling it as. So beta generally in the exams, instead of beta 50, they will write HFE equal to 50. So don't get confused. In the biasing problems, they may give you HFE equal to 50, and you may surprise that we are we don't have any HFE in the biasing equations anyway. We have only beta. So HFE is nothing but the forward current gain. The beta current gain is nothing but the HFE. So both are same. So out of this, from today's class, you you have to remember only, out of this class you have to remember only these two equations. I will write one more time. Output current I naught is a function of input current and output voltage. Okay. So therefore, I will write I will write that output current I2 is a function of input current and output voltage. And we are left with V1, the variable. So these two are dependent, right? So V1 is again function of I1 comma V2. So the exact mathematical equations which relate this terminal currents and terminal voltages is H parameter equations. As the H parameters, okay, H parameter equations. So why we have taken H parameters means using H parameters, we can we can get the information about the input impedance of the device, the voltage gain of the device, current gain of the device, output admittance of the device. So all the four parameters we will know using H parameters. That is why H parameters are chosen to represent the electrical behavior of the transistor. So finally you need to remember only these two equations. You need to remember only these two equations. The same two equations I will write it as I2. All of you see here I2. So these are the two equations you need to remember. If you remember these two equations, you can easily draw the H parameter model. You can easily draw the H parameter model. Now I am going to call H11 as HI. This is HR. This is HF. This is HO. So these are the equations pertaining to the transistor. If it is in network analysis for some other circuit, we can use the same notation 1, 2, V1, V2. H11, H12, H21, H22. As we are applying these H parameters to the BJT, we will use this notation of H parameters, HI, HR, HF, H0. So if you know these two equations, if you can remember, if you can understand how we have written these two equations, then you can easily draw the H parameter model. So I have already asked Sir Sriyandarajan sir that I am going to leave 15 minutes late. One second. Sir also have not yet posted the link, right? So here, same thing, whatever we discussed, written here. H11, H12, definitions of the four H parameters. So H parameter model. This is the H parameter model. So this is the H parameter model. So H11 is see here, H11 is an impedance, right? So therefore, I will introduce a resistor in the input circuit, H11. Next, H12, V2. You see here H1 to V2. H1 to it is a voltage. It is a voltage quantity. V by reverse voltage transfer ratio. Voltage into voltage. So it is voltage only. So this is a voltage quantity. It is a voltage quantity. Therefore, for this, I am going to introduce a voltage source. I am going to introduce a voltage source whose magnitude is H1 to V2. H1 to V2. Now you see, if V1 is the input voltage, if V1 is the input voltage and I1 is the input current, if I1 is the input current, then if you apply KVL, if you apply KVL to the input loop, you will get that first equation. To apply KVL, applying KVL to this input loop, you will get this equation. And coming to the second equation, output current, okay. The second equation, now see here, H21 I1, this term H21 I1. So it is a current, H21 is the forward current gain, right, into current. So this is a current quantity, it is a current quantity, is a current quantity. Therefore, what I will do, I will introduce a current source. I will introduce a current source and the magnitude of that current source is H21 I1. So output current is sum of the two currents. So this current already, this term represents the current. So I have introduced a current source in the output circuit. And the second term, this is second term, H22 V2. What is H22? H22 is I2 by V2. V2, right? So this is also a current. So this H22 into V2 represents that H22 or 1 by H22. You can write anything. Some of the textbooks they will write H22 and some they will write 1 by H22. Okay. See here, if H1 by H22 is the H22 is the admittance and 1 by H22 is the impedance. Now, if V2 is the voltage across the output terminals, the same voltage will appear across this branch. So current through this branch, current through this branch is V by current through this branch. What is the current through this branch? Voltage by resistance. Voltage V2 by 1 by H22. So therefore, H22 into V2. So same thing has written here. So this term represents current through the resistance 1 by H22. So sum of the current through this branch and this branch will be nothing but the output current of the two-port network I2. So therefore, if you apply KCL at this node, you will get this second equation. By writing KCL at a node, second equation you can get. So this is the H parameter model. So from equation 1, the first term H11 I1. Okay. So this from this equation I will close in another 2 minutes. This represents that the drop voltage drop across HI. Therefore, what I have written, I have introduced a resistor HI, and the current through that resistor is I1, and V1 is HI into I1 already done, and this is a voltage quantity. Therefore, I have introduced a voltage quantity which are V2. So if you apply KVL to this loop, you will get the input voltage V1 as sum of the voltage drop across HI input impedance plus the voltage source. So that is what we got this circuit. And in similar manner, I2, these are the output terminals. Let us say that these are the output terminals. So the output current is, this is a current quantity, HF into I1. We identified that it is a current quantity. Therefore, I inserted a current source whose magnitude is HF into I1, and I have inserted a resistor 1 by H22, and the current through this branch, current through the branch 1 by H22 is, what is the current through this branch? V2, V2 divided by 1 by H22, V by R. So 1 V2 by 1 by H22. So V2 into H22. So the same thing is remaining. We can do. So by applying KCL at this node, you will get second equation. By applying KVL to this loop, you will get the first equation. So using this model, we will analyze the amplifier circuit. This is only the transistor model, not the amplifier circuit. So amplifier means a AC signal source will be there in the input side and a load resistor will be there in the output side. We are not connecting any source and load resistors. So this is just the equivalent model of the transistor only, not the transistor amplifier. Whatever the parameters, H parameters we have defined, these are the H parameters of the transistor only, not the H parameters of the amplifier. Make it clear that input impedance of the transistor and input impedance of the amplifier both are different. H11, H11 is the input impedance of, I'm writing one more time, input impedance of transistor, not the transistor amplifier. So using this model, we are going to find the input impedance, output impedance, current gain, voltage gain of the transistor. So in the next class, we will draw the H parameter model for all the three configurations, CB, CE and CC, how to draw the H parameter model for the three configurations. Next, we will analyze the amplifier using H parameter model. So here we are going to add source and a load. Then whatever the transistor block is there, that we are going to replace it with its H parameter model. So this is the H parameter model. To the left of it, source is there. To the right of it, load resistor is connected. Now this is the final equivalent circuit of the amplifier using H parameter model. So I'm closing here. One of you please send me the attendance.
I have noted, madam.
Okay. So do attend the classes, because once you understood the basics of H parameters, how we are drawing the circuit. Understanding means how we are drawing the circuit.